Good morning, Angelo, Harmony, Lakeland, Omar.
Good morning.
Good morning.
As I told the others, I did not take time to do minute fluency or bearing today. So we're just gonna go ahead and keep it moving. Today is Monday, March 1st, 8 SP3. I can write equations for the line of best fit and scatter plot 65% max. So last week we talked about scatter plot. Anybody remember what it looked like or what we did with it? Yeah. What it looked like? Dots on the graph. What things did we say we can identify with those dots? Forgot? We was already doing it. I got the definition. It said graph order for. Okay, so they gave us the graph, and then Jacoby said he noticed we made a line through it, so that is correct. So today we're gonna move from making the line, and then we're going back to what we did with equation. Write it in slope intercept form. Why? Because then it's supposed to be. Good morning, India.
Good morning, Miss Cassie.
All right, I always remember that we are champions, regardless of how your weekend went, Corey. You still a champion. All right, some vocabulary in case we didn't get it or whatever. A best fit line or a trend line, we learned this on Thursday. It minimizes the distance between the actual data points on the line placed on the graph. That means all those dots need to be as close to the line as possible. All of them won't touch the line, but they all need to be close to it. Then, of course, y-intercept, we've been looking at this since school started. There's where the line crosses the y-axis. And then, of course, the slope is the change in y values divided by the change in x values. This is how we find slope. 2 points in order to do so. y2 minus y1 divided by x2 minus x1. And that remains the same from now through high school algebra, college algebra. It's the same. Linear equation we've looked at since the start of school. It shows us the slope and y-intercept. Y equals mx plus b. M is always the slope. B is a y-intercept. So we know equation form, how to find the slope, how to find the y-intercept. We good. Any questions about it? All right, equation y equals mx plus b. All right, did your practice load up? Say error. All right, you may want to try to exit out or take you out a piece of paper. You have to work simultaneously. Just to make sure you got charged. Exit all the way out, and then you may have to try to go back in. If not, take you out a piece of paper, and that way, get it as we go along, and then go back and get what you need. All right, number one, several stores in Centerburg sell 24 stick packs of Juice Yum gum. The stores charge different prices. They also sell different numbers of packs per month, as shown in the data and scatter plot. Write an equation for a trend line that does a good job capturing the trend of the data. Check on the research she makes it. Kind of like when we stay up classroom, sometimes it's showing, sometimes it's not. All right, so they want us to write an equation. Before we can write that equation, we must draw a line. Will that line be positive or negative? Good job, it will be negative. And you need to kind of go through all your points. And you need to touch a few. Not good enough. All right, the equation form, y equals mx plus b. Which one can we easily identify on the graph? M or B? Which one can we easily identify on the graph? Good job. What is the y-intercept of this graph? All All right, it looks like it's at the top. They're counting by 10, so there'll be about 10 and then another 10. The Wi-Fi. First class, it worked fine. The next class, it acted funny. The last class, it worked fine. So I guess this class is acting funny.
What was the question you asking us?
The y-intercept, and we found it up here at 220. We're across that y-axis. Then it's going faster.
Hey.
All right, so that y-intercept is gonna be one of our points at 0, 220. Somebody see if you could possibly give us another point that's on that line. It has to be touching the line this time. I see quite a few that we could possibly use.
We can use like 2.9, and whatever the number is between 180 and 200.
What number is between 180 and 200, Harmony?
It's a lot of them.
What is it? Oh, okay.
Let's pick one.
She said 2.9 about. She said 2.9 and about 190. All right. Slope formula, y2 minus y1 divided by x2 minus x1. All right, what's our y2? X2, I mean y1. Y1? I'm going to get some off the focus on making that time though. All right, x2 and x1. Good. Somebody subtract. Somebody say something. All right, simplify, or in other words, that's about negative 30 divided by 2.9. Or I would say 3. I probably rounded it 2.9 to about 3. All right, negative 10. And how do we know it should have been negative? Outside of doing that. Outside of doing that, how do we know it should have been negative? Good job. So that's one way of helping me identify if my slope is correct or not. Since we got a negative line, that means that slope needs to be negative. So we found the slope, we found our y-intercept. What's our equation? All right, that's the y. What's the slope? Or you can write it with the slope in the front, y equals negative 10x plus 220. And that will both be the same thing. So you need one or the other. Of course, you need to know how we found that slope. Any questions about it? Okay, let me know when you get it. So they're gonna give us the graph, we make the line through the graph, and then we pick out two things, find slope and the y-intercept. All right, anybody else? All right, number Number 2 says Madison is monitoring the temperature over several hours. Her data are shown in the table. She draws a line of best fit with the equation y equals negative 6.2x plus 64, where x represents the hour and y represents the temperature. Describe the meaning of the slope and the y-intercept in this context. All right, so they gave us this equation. What's the slope? What's the y-intercept?
The slope is 64. I think.
All right, Harmony, slope always with x. Slope is always with x. That's all right. That's slope, and then b is the y-intercept. All right, so they said in context of this situation. What's going on? She is monitoring the temperature over several hours. So we're talking about temperature. So what does that y-intercept tell us? Okay, which is what? What it was at first. Good job. So the y-intercept of 64 is the starting temperature. All right, what's the slope? Negative 6.2. What does that tell us? Good job. Every hour is dropping 6.2 degrees. And we can say drop because we know it was negative slope, so that means that it is decreasing. So anytime they ask you to identify the slope and y-intercept in the context of the situation, just think about what the situation was referring to. And remember that y-intercept is always where you started or your beginning value. And then slope tells you how it's increasing or decreasing each time. And what they tell us. Any questions about it? Anybody? Anything? Okay. Oh, okay, right there. They working on it. Right? You see them? They right there on the ladder. Oh, you like they looking at it. Look at me being out. Oh no, they figured some things up. They figured some things up. Some parking things. Yeah, let me pause.
I'm done.
You said they had well, I know they be trying to keep the handicap parks, and then somebody always parking them. So maybe they just want some signs so we'll know where to park and where not to park. Now, I can say that I have, and the thing with that be somebody be already in the park, and then they have to park somewhere out here, and you try to see them moving on the little cane or something. I have. It's very difficult. Oh yeah.
Get it back in blood. What? Why would you do that?
You see it. Jenny recorded the height on the water in the bathtub and it drained after she pulled the plug. Her data is shown in the table and the scatter plot. Write an equation to model the approximate height of the water. So once again, before I can write that equation, I'm going to draw my line. It is negative, isn't it? My line, I would say that wasn't a good line. That means the slope will be negative. Whatever the association is, that's how the slope will be. Look, you see how many times I done erased it? But we gonna make that one work. All right, so our y-intercept, we're gonna say is about what? 20. All right, we need 2 points, so that'll be our first point. See if you can find another point that's touching the line. Pretty cricket, so I apologize. 45. Let's go with this one. So 40 by what? 7. X2, Y2. And the way I taught it first semester, if you need to label your 2 points, so when we start substituting into the equation, so you know which is which, be my guess. All right, y2 minus y1 divided by x2 minus x1. All right, what's y2?
7.
y1. I had to make sure the number was correct. And then x2. And then x1. All right, divide out. You will learn that anytime the slope doesn't divide out to a whole number, we would typically leave it as a fraction. So we can leave that slope alone. So now we have y equals to negative 13 over 40x. And then we said that y-intercept was 20. Somebody identified earlier it was negative, so the slope will be negative. So that'd be one way of checking and verifying if we correct. Any questions about it? I got it? All right.
I could give it back in blood.
Nah, that was I guess you want to make sure we heard it was up. Y'all got it? All right, it says the table and the scatter plot show the total weight for a quart container of strawberries at Marty's Market. They gave us the table, they gave us the graph. It says the points 3, 5.5, and 9, 13.5 lie on the line of that fit. Which of the following is the equation of the line? Now, which one did we say we could easily find when looking at the graph? What's the y-intercept? So that means that's the first thing I'm looking for, something with a y-intercept of 1.5. Good, D can be gone, and then C can be gone because that 1.5 is above 0, so it'll be positive. All right, so we got different slopes, 3/4 and 4/3. So now how can we find the slope? Good. So I'm gonna use these 2 points they gave me, and we're gonna substitute them into that equation. X1, Y1, X2, Y2. So what was Y2? Y1. Good job. X2. And then X1. Subtract. All right, simplify. B will be the correct answer. Y'all, she chose A. How do y'all think she got A? Good job, I like it. So I would say the correct answer is B. Yashi got A because she did the slope backwards. She did x2 minus x1 divided by y2 minus y1. It is a fraction bar in there somewhere. I just don't know what's it. But some of the other ones have figured it out. If you haven't, you can just put the little slash. Plus sign from the right. Cool, they got you right. All right, we done tapping. All right, number 5, the scatter plot compares the number of mistakes Kobe makes playing a song on his trumpet and the number of hours he practices the song. A line of best fit is shown. True or false? A says the equation of the line of best fit is y equals to x plus 6. All right, think about an equation. What's the first thing we can easily identify? Is the y-intercept 6. All right. What should the slope be? Is it negative? It's going down, so we know we need a negative slope. All right, part B says the slope means that you can expect the number of mistakes Kobe makes to decrease by 1 for every 1 hour increase in practice time. Decrease by 1. All right, now we said it shouldn't have been positive. Somebody said it was negative. So can we say it's decreasing? That will be correct. All right, and then part C says the y-intercept means that you can expect that even if Kobe does not practice, he would only make about 6 mistakes. Is that what that y-intercept tells us? So that means 0 hours of practice. Then they saying here, I only make about 6 mistakes. Yeah, that would be true. Yeah, because 6 was the y-intercept. So it's pretty much saying the less time he practiced, the more mistakes. But as he keep practicing, as he went down to 4 hours of practice, he only had 2 mistakes. Will be correct. Any questions about it? All right, notice we didn't do anything with this. It was just based on us knowing if that slope should have been positive or negative. All right, number 6 says the scatter plot compares the number of oranges remaining at a fruit stand to the amount of time that the stand has been open. It says draw a line of best fit for the scatter plot, write an equation to represent the line, and then it asks us how many hours after opening would you predict that the fruit stand will sell out of oranges. All right, first thing, let's draw a line. It looks right. It looks right enough. We're gonna go with it. All right, so looking at that, what would we say our y-intercept is? Not quite at 40. Okay, we'll go about 37. Give us another point on that line. Oh, 25. Okay, we'll go with it. Look like about 24-ish. Let's put it for 24. Same formula for slope. Y2 minus Y1 divided by X2 minus X1. All right, so what's our Y2 and Y1? 24, 37, X2 and X1. All right, somebody subtract. All right, so we're going to leave it like that. It didn't simplify. All right, so our equation, y is equal to negative 13/4 x plus about 37. All right, they want us to predict when will we be out of oranges. Out of oranges would pretty much be when the y-intercept is what? Good job. So if we were to put 0 in for that y-intercept inside, all right, first step would be to get rid of that 37. So now we got negative 37 is equal to negative 13/4. All right, now divide negative 37 by negative 13/4. What you got? Okay, so if you divide 13/4, that's what? 3 1/4? 3.25? All right, so now take negative 37 and divide it by negative 3.25. 11. All right, so it'll take about 11 hours to sell out of oranges. All right. Any questions about it? All right, everybody got what you need? All right, the amount of sports drink in a cooler during practice is modeled by the equation y equals 648 minus 24x, where y is the number of ounces in the cooler after practice and x is the number of players at practice who take drinks from the cooler. Based on the information, they want to know which is true. It's a true vol question. All right, part A says the cooler is meant to be used by only 24 players. What did they tell us represent the players? Do we know how many players right now? All right, B says before practice, there are 648 ounces of sports drink in the cooler. Why you say yes?
Because that's the initial value.
Good job. Initial value or the y-intercept, for those who know what is that. All right, C says each player drinks approximately 24 ounces of sports drink at each practice. All right, we said we didn't know our players, but we do know X is for the players. What's with X? So yes, that would be correct. That's the slope. All right, D says if 24 players get drinks from the cooler, they would drink a total of 648 ounces. Let's see, 24 ounces each, and they told us we got 24 players. Somebody multiply that. All right. And then E says for each additional player that takes a drink, there will be approximately 24 fewer ounces remaining. The slope negative 24, that means each time somebody drink, they're taking away 24 ounces. Good. Part B says at the end of practice, there are 240 ounces of sports drink left in the cooler. Every player had some sports drink from the cooler. Based on the equation, how many players were at practice? So if I got 240 left, 240 is now my what? Good job. So we're going to use that same equation, except now we're putting in 240. All right, so it'll be our first step to get X by itself. Something else over there.
Subtract 24.
Something else over there. All right, so subtract both sides by 648. All right, so now we have negative 24x is equal to what? No, the total is 648. But down here they told us we got 240 left. So that's why 240 became our y-intercept. They saying they started with 648, Jacoby, and then at the end of practice, they looked over and they had 240 left. All right, so now divide by negative 24.
$17.
All right, so that means it was about 17 players at practice. All right, any questions? Everybody got what you need? All right. I'm not sure how many we got today, but we're gonna try to get as much as we can. 12? Okay. Amelia and Alex are studying the growth of a plant over time. They measure the height of the plant at the end of each week for several weeks and display the data in the scatter plot. Then they find the equation of the line of best fit to be y equals 2.5 plus 1.25x, where x represents the week and y represents the height of the plant at the end of the week. They want to use the equation to estimate when the height of the plant would be 10 inches. Amelia's estimate is after week 6. Alex's estimate is after week 15. Is either student correct? All right, think about what they said. They gave us the equation. We're growing a plant. They want to know the height of the plant, when it would be 10 inches. Amelia said at week 6. Alex said about week 15. 10 inches. What would that turn into? Is it our X or our Y? Good job. Y. So top, Y gonna be the height. So we're gonna substitute that in the equation and see what we get. 10 is equal to 2.5 plus 1.25x. What's our first step? Good job. Subtract 2.5 on both sides. All right, so now we got 1.25x is equal to what? All right, now what? Good job. Divide by 1.25. X is equal to 6. All right, so we would say Amelia is correct. They said explain. Because I substituted 10 into the equation and solved and got 6. He was did something screaming wrong because its value is a whole lot more than 6. I wonder what he was doing to get 15. Everybody got what you need?
No, ma'am.
All right, let me know when you get it, Angelo.
Got it.
All right, number 9. Kiko and Eric each randomly surveyed people with cell phones. They recorded people's ages, years, and how many texts they send per day on average, T-text. For their respective data, they each drew a line of best fit and determined its equation. They then compared equations and made inferences based on the equations they calculated. Determine whether you agree or disagree based on the equations above with the inferences drawn below. All right, A says, the younger A person is, the more text per day he or she is likely to send. All right, now let's look at these equations. We got Kiko, we got Eric. These y-intercepts will represent where we started. And then they're decreasing by this amount every time they send a text message. So we just say the younger a person is, the more text he or she will most likely send. All right, let's put some numbers. If I got negative 1.63, let's say I'm 3. Somebody multiply that by 3. Negative 4.89. All right, and let's say I am 15. $24.45. All right. So if I started with 92 and I take away 4 and I take away 24, which one took away the biggest gap? 15. So does that mean the older I am or the younger a person is, the more text they gonna send? Hmm. 15 took the most. So they'll be disagreeing. That's like a baby. A baby not texting too much, but by the time they get to y'all age, they texting. All right, B says the people Kiko surveyed send more text on average than the people Eric surveyed. All right, once again, I don't know. Somebody give us a number for A. How much? 6? 7? All right, substitute it in for both equations. We're gonna try it with the second one. Add 92.14. All right, that do negative 105 times it. 1.05. 0.05. Add 80.97. All right, so they said Kiko people send more texts. Yes or no? It was high. C says the white intercells have no relevant meaning because people who are 0 years old cannot send texts. They say that white intercell won't have no relevant meaning. You said agree? Why you say agree? Okay, I kind of see what you mean. But then it kind of makes me question and wonder. But think about that. Because if I'm 0, that means that'll go just to that white intercept, 92.14 and 80.97. So we gonna have a meaning. But I guess this piece right here, 0 years cannot send text. I'm gonna go with you, James. Only because of how they worded it. I feel like they would, yeah. But then when you think about it, yeah, 0-year-old not sending text. But according to this, they're gonna send about 92 a day. All right, D said Kiko's trend line suggests that for every 1.63 year decrease in age, people send an average of about 1 fewer texts per day. All right, let's go back up here. We did 163 times 3, add 92.14 to that. And what? Negative 4.89 and add 92.14. 92.14. So it should be negative. 80 what? Point what? All right, now do it for 4. Multiply 4 times negative 1.63. And add 92.14. 90 what? 0.61. All right, so did we see about an average of 1 fewer text message? Y'all make me want to do calculations. Somebody check that for the second. 85.62. All right, now that may be more likely. So that's about 87, and then we're gonna say that one is about 86. So will we say that's 1 fewer? Yes. All right, and then you know, silly, something we didn't need or something. Eric's trend line suggests that for every 1 year increase in age, people send an average of about 1 fewer text message. And go back to D. Because D said 1.63 year decrease, the people send 1 fewer. So we should have decreased. From 4 to 3, did it decrease? It increased. So this one should have been disagree. And then for the bottom, they said Eric got for every 1 year increase in age, people send an average of 1 fewer. So let's see. We did 7 earlier. Do 8 for the second equation. Substitute in 8. So 8 times negative 1.05. And 80.97. 72.56. 57. All right, so we would have had 73.62. So we're gonna say about 74, and then it came down to about 73. So let's say 1 year increase, we get 1 fewer text messages. We would agree with that. All right, any questions on it? Everybody got what you need? Okay. 10, 11. Okay, 2 more. Go ahead. George and Martha go to different schools. Each collected data on students' heights in H inches and weights, W pounds at their own school. For their respective data, they each drew a line of best fit and determined this equation. They then compared equations and made inferences based on the equations they calculated. Decide whether we agree or disagree. A says, George states that the students that he surveyed weigh more on average than the students Martha surveyed. All right, look at those y-intercepts. So George got 250.67, Martha got 232.24. The 233? You said something, you might. You agree? All right, B says, Martha states that her trend line suggests that for every 1 inch decrease in height, there is a decrease of 232.24 pounds. Every time it increases, do we decrease 232.24 pounds? They're saying you're going to multiply her inches by 5.94, and then we're going to take away 232.24. All right, let's try it out. Give us some numbers for, wait. All right, so do 594 times 300 and then take away 232.24. Mm-hmm. All right, take away 232.24. All right, and they said 1 inch decrease. So now do 5.94 times 299. And you took away 232.24. You said 48. All right, so they said 1 inch decrease. There's a decrease in 232.24 pounds in weight. Was there a decrease in that amount? $15.49, $15.43. Is that enough to say 232 pounds gone? It looks like just 1. 2 at the most. All right, George states that the trend line indicates that for every 6.22 inch increase in height, there's an increase of 1 pound in weight. Now we're talking about George. Y'all stick with 300? Is it 866? 1,866. All right, and then they say we're doing what? Increasing. So do 301. Oh, it's subtract. I'm sorry. $1,600, and you said point 33. Gotcha. So then multiply 6122 times 301. Take away 250.67. So they said as we increase in height, we increase a pound. So if I went from 1615 to 1621, did I increase by 1? All right, George said that his equations intercept of negative 250.67 has no relevant meaning since negative weights are not possible in the real world. Can I be negative? Good. Yeah, so we gotta agree with that. It don't make no sense, which is pretty much correct. That's what was throwing me off first. I'm like, wait a minute, why they subtracting it? But anywho. So then E says, Martha says that for every 1 inch increase in height, there's a 5.94 increase in weight. That was Martha. Increase. So if we went from 1543 to 1549, what we say that was about 5.94 increase. Yep. Any questions about it? All right. It's lunchtime, but we're gonna try to go ahead. Is that all right with you all? Got one more. The last one take you to upload. All right, Sandy surveyed her classmates to find the number of video games they owned and the number of hours they spent. Look like they went ahead and gave us the line. How can Sandy interpret the trend line? All right, so we just need to know the meaning of her equation. What's the y-intercept? All right, is she talking about video games on? All right, she's talking about the number of time they spend in front of the TV. What's the y-intercept? Look at they got you the equation. 10.5. So we would say the y-intercept of 10.5 mean what? Average person spends 10.5 hours watching TV. I'm gonna say in front of TV because that's what they said. All right, what's the slope? All right, what they tell us? All right, tells us that for every video game down, there's an increase of 1.8 hours in front of the TV. Good job. And that is the last one for today. So that means all of us, whether you here or whether you at home, should be doing what? Submit. So after you get your little piece, you can go ahead and submit. Those of you at home, you can log out after you get what you need. We're about to get ready to go to lunch.
I have a question. But this is about the bi-weekly assignment. Are we gonna do that in class or are we do it at home? I don't know.
You doing it on your own time. Just make sure it's done before March 12th.
Oh, okay. Thank you.
You got it. Go ahead and line up. We're gonna go ahead and go to the cafeteria. I think it don't stop, but I'm gonna put my jacket on anyway. It may be chilly. You go ahead, Mariah. You fine, Johnny. Go ahead and get what you need. Oh, I thought we were doing.
Clarification.
All right.